Hello everyone. So far we have learned variables and data types. We will now look into how we can create and use functions. In Rust, a function is a named block of code that performs a specific task. You define it once and use it wherever you need. Functions help make your code organized and usable. You have already seen a function called main, which is our entry point to the Rust program. We use the keyword fn to declare a Rust function. Keywords are certain reserved words or combination of letters used to perform certain predefined actions in the programming language. And main is the name of the function. It means that this is the name of the block of code. So whenever this block of code needs to run, we use this name. Using this function, let's try to calculate area of a rectangle. We declare the length as 4 and breadth as 5. Now we print the area using this println macro. Macros are not functions, though it may look like one. We will discuss it later in this series. The area is printed as 20. Since main is the entry point of the program, the call to this function by the compiler is predefined. We can also create functions and call them as we need. We tried to find the area in this function. Now let's create another usable function to get the area. We are giving the name of the function as findArea. One thing to note, Rust follows snake case as the naming standard, so multi-word names are separated by underscores. In the main function, you have seen two parentheses right after the name main, but they were not enclosing anything. Here, in this function, we are writing some things enclosed by those parentheses. These are called function parameters. Basically, these are the variables which captures the value passed to this function from where it is called. We are taking two values, length and breadth, both as i32 values. While declaring function parameters, it is mandatory to mention data types in Rust. Without them, the program won't compile. We are printing the area in this newly created function using the two parameters. Double slash is used to comment a line. It means that the commented lines are considered as simple text and not part of the executable program. We are commenting this print statement in the main function since we are using the same in the new function. Now to call this function, we just use the name of the function and then the values we need to pass to this function enclosed by the parentheses. Now if we run this program, it will print the same result, area as 20. Here in the main function, we already have declared two variables with the values and passed them to the new function. We can actually pass those values directly into the function as arguments. Result will still be the same. Since we created a function, we can call it as many times we want. Let's try to find area of another rectangle. Now we get both the areas printed. Here, we are printing the result in the new function. Instead, we can use the function to just calculate and get the calculated area back to the place from where it is called and then print it. But in our current setup, nothing is returned from the function. In Rust, to return a value, we use a hyphen and greater than symbol followed by the data type of the return variable. If a function is not returning any value, then the compiler infers that it is returning a unit type. Unit type basically Rust's way of saying nothing or no meaningful value. It's the Rust's version of void in other languages. But it's still a real value, it just carries no information. It is denoted by something that looks like an empty tuple. To return a value from the function, we need to understand a concept that is super fundamental in Rust: the difference between statements and expressions. So, in Rust, almost everything is an expression. That means it evaluates to a value. For example, 5 is an expression. X plus 1 is an expression. Even entire code blocks like this, that's an expression too. And it actually returns a value. Now, on the flip side, we have statements. These are the parts of your code that do something, but they don't return a value. A common example is let statement, like let x equals to 5. It sets something up, but it doesn't produce a value you can use directly. One important thing to watch out for, adding a semicolon to an expression turns it into a statement. So if you write x plus 1 with a semicolon, you're telling Rust, hey, I don't care about the result of this. And that's why in Rust functions, you often see the last line without a semicolon. This is because we want to return the result of this expression. In the function we wrote, the line where we're returning the area isn't including any semicolon. That is why that's an expression. And it's what actually gets returned. Add a semicolon by mistake, and you've got a bug. Semicolon turns the result into a unit type. So just remember, expressions return values, statements perform things, and the semicolon is what often makes the difference. Now we are able to get the area of a rectangle by calling a function. So we can call it multiple times to calculate area of any other set of values. Here, the first line prints the area of sides 4 and 5, and the second line calculates for 15 and 35. In Rust, we also have function pointers. It means that we can assign functions to variables. This helps enable higher order functions. A higher order function is a function that takes other function as parameters, returns, can also return a function. Here in our example, we are creating a variable called area and assigning the findArea function to it. This is the syntax to denote function data type for this variable. You can see we need to specify the data types for the parameters as well as the return type. Now we use area variable to call the findArea function, and it will behave exactly the same we have seen so far. Rust also allows nested functions. It means that we can define a function inside another function. You might be wondering by looking at the implementation, if I define a function inside another function in Rust, why do I still have to specify all the parameters for the inner one? Shouldn't it just be able to see the variables from the outer function? So even though length and breadth are clearly defined in outer findArea function, we still need to pass it into the inner. Why? Well, here's the thing. Rust doesn't allow inner functions to automatically capture variables from their outer scope. At least not for regular functions. Well, technically yes, we can achieve this by using closures, but that is not in the scope of this video. We will look into closures in a separate video. For now, we need to treat the inner function as if it is a standalone function, despite being written inside another function. You can see it prints the length and breadth of the values as expected. I have to mention one thing here, that Rust doesn't support method overloading. We need to use different function names or enums for different variations. Rust also doesn't support variable arguments, but it does allow recursions. We can also use generics for functions. Generics let you write code that works with many different types instead of repeating the same logic for each one. We can also use lifetime in functions as well. And if we want to add metadata to the function, we can use function attributes. It may not make much sense to you now, but we will cover all these topics as we progress. This is all about functions in Rust. We have learned quite a few things now. It is best for you to try these out by yourselves. Only by writing code you will be able to fully understand when and how to use any of these features. That's the end of this video. We'll see you in the next one.